So for the agenda for today, we will have, first of all, the welcome remarks from Claudia Alvarez, who is the head of the C42 project. And also after that, we will have Philip Denziger, who is also working for the GIZ Proclima, and he will present the promotion of the R290 split ACs at global level. And after that, we will have Daniel Borner from HEAT, who will give us a presentation of the latest update of the R290 resource guide. And finally, we will have a question and answer sessions in order to address any questions that you may have. But now, let me introduce Claudia Alvarez, the head of the C42 project, who will give us some welcome remarks. Claudia, the floor is yours.
So again, dear ladies and gentlemen, thank you for being with us today on behalf of GIZ Proclima. I welcome you to this webinar on R290 and the role and the potential of propane in sustainable cooling. As Paola already mentioned, this event is the kickoff for the new series Green Cooling webinars by the Green Cooling Initiative project, GCI3. And it's also organized in cooperation with the Cool Contributions Fighting Climate Change project C42 and its NDC4 webinar series. The two projects are part of the International Climate Initiative, the ICI, and financed by the German Federal Ministry of Environment, Nature Conservation, Nuclear Safety, and Consumer Protection. So with regard to the subject, when we look at the rising demand for air conditioning that is ongoing right now and which will come up even bigger in the next 20-25 years due to population growth, urbanization, and climate change, then we see that there's a huge threat, let's say, in front of us if we don't act accordingly and in a sustainable way to get greenhouse gas emissions down. Because if we see the global warming potential of traditional refrigerants such as R222 or R410A or also R32, then we see if we continue using these refrigerants, then with the high demand, the greenhouse gas emissions will rise. So we have a huge potential in making a transition to R290 in air conditions, and therefore we investigated on it, and the results and applications in field will be presented today. And yes, I'm very happy for this, or in the kind of in this webinar to learn about these things for you, and I wish good presentations and fruitful discussion afterwards. So thank you very much for joining today, and I will hand over back to Paola.
Thank you very much, Claudia. And sorry to hear from our colleagues that they had some problems with the connection at the very beginning, but now we have heard Claudia and we can continue with our presentation and also with our agenda. Now I'm pleased to introduce Philip Denziger, who will share practical application of R290 in the cooling sector. Philip is a component leader at the GIZ Proclima, and he is based in Kenya, where he actively promotes sustainable cooling solutions worldwide with a strong focus on implementing green cooling technologies, particularly in Africa. Before joining GIZ, he gained experience in the automotive industry, and in his presentation, he will highlight the importance of using natural refrigerants, especially R290, emphasizing their energy efficiency and also the environmental benefits. Philip, the floor is yours.
Thank you so much. Yeah, warm welcome from my side from Nairobi. I live here now and promote R290, but not only in Kenya, all over, and also outside of Africa. So I want to talk a bit about ProClima very briefly. We've been working for like 30 years now under the Montreal Protocol, but also are working under the Paris Agreement. We're promoting. I mean, we work on the preparation of the Kigali Amendment. Also, we work in ozone layer protection, but also climate protection. We are working mainly for the German government, but also for other ministries and other countries. And our goal is, to promote and introduce natural refrigerants globally, and also to promote energy efficiency. So what we do, as I mentioned, we work under the Paris Agreement, we work under the Montreal Protocol, the Kigali Amendment, but we also consider the energy policies and strategies. So we try to bring them all together, because cooling is quite a big topic when it comes to emissions, to energy consumption, but also when it comes to food losses or whatever. Cooling is getting more and more important. And we also try to bring in the Sustainable Development Goals. So this is our objective. And we usually work also with the Climate Office, with the Ozone Office, and the Energy Efficiency Office. We bring them together in around 40 partner countries. So what we try to do is we switch instantly to green cooling technologies. We call it leapfrogging. So we don't want to move to HFCs or another HFC or a blend or an HFO. We say for most applications, we have green cooling technologies available. They're more efficient. They have a lower environmental and climate impact. So we really want to and we've demonstrated it several times that leapfrogging is possible, that we skip another conversion, another conversion, another conversion, and go straight to natural refrigerants. And the same we are planning to do for the air conditioning. So today we focus a lot only on split air conditioning, because split air conditioning is the most relevant sector, I would say, when it comes to the emissions, to the energy consumptions, and also the growth of split ACs is growing significantly. And so split ACs are the most common appliances that are used for air conditioning. And often these appliances are also very inefficient, and as mentioned, they are harmful to the ozone layer or climate, and have environmental and climate damaging refrigerants. So they account for the biggest proportion when it comes to emissions, but also in terms of electricity. In 2016, we had 10% of the global electricity consumption was accounted to split AC. And in 23, it's already 20%. But under the business as usual scenario, the air conditioners are growing tripling up to 2050. So the sale of new air conditioners, so every 10 seconds, every second, 10 new air conditioners are sold for the next 30 years. So, I mean, looking at the numbers, that means in 2016, we had 0.85 billion. And in 2050, we will have 3.7 billion ACs, split ACs. So we really need to focus on that RAC subsector. And I mean, our market assessment of GIZ have shown that a transition to higher energy efficiency and R290 ACs plays a crucial role for a more sustainable RAC sector. And if we now would introduce split ACs, only by 50% share, we could cut the total emissions by 25% up to 2050. I like graphs and numbers, so just they're more active. In 2012, the US consumed more energy than air conditionings in the entire world. And in 2021, Africa already consumed as much. And in 2100, India will consume 14 times more person cooling days than the US. So, I mean, you can see it's growing crazy, and that's why we believe it's a low-hanging fruit and we should focus on R290 split AC globally. In terms of refrigerant consumption, same story. It's growing significantly, and small and medium-sized equipment accounting for the majority of refrigerant consumption. Daniel will present this table in more detail. You can just see, okay, we used R22, we are now using 410A, we're using R32, but looking at the global warming potential, and also especially the global warming potential over 20 years, and because we want to fight climate change now, and looking also at PFAS and TFA, so the environmental side of it, we can see that there's not a lot of options left. It's actually only propane or CO2 that would be a suitable environmental, climate, and ozone-friendly refrigerant. But Daniel will talk a bit more about this table. He has a similar one in his presentation. So looking at the global mitigation potential of R290 split ACs, it's accumulated up to 125 gigatons up to 2100. So we're talking quite about a significant part. And compared to the HFC 32, the R32 scenario, it would be still 64 gigatons. We know that R32 will be phased out or down under the Kigali amendment. So it's not a suitable solution, long-term solution. And so R290 has, according to this study, a tremendous impact globally in terms of mitigation potential. And what does it mean in terms of Celsius? So it can avoid up to 0.1 degrees Celsius if we would introduce R290 ACs now. And this is quite significant because we are not having a lot of time. I cannot go into all the details, but you're getting the slides and then. So looking at the Kigali schedule, we know we have to reduce, depending on the group, we have to reduce our HFC emissions significantly. And even, I mean, though we have a bit more time, the first reduction of 10% might be still feasible for the A5 countries. But the next step in 35 of 30% will be significant. And then it will, I mean, the countries will really have to look at ultra low GWP refrigerants, especially in the AC sector, because the AC sector is consuming most of the refrigerant, and it's growing. And I mean, we cannot just wait up to 35 and then start introducing R290. We know that the sector transformation takes time. We need to train all the technicians. We need to get familiar to the technologies and so on, look at the standards in each country. So we need to start now. We cannot wait much longer. I just copied in the European F-gas regulation, the revised version. There, from 29 onwards, R290 will be hopefully the main refrigerant in split ACs below 12 kilowatt. And in 35, we will have no more F-gases below 12 kilowatts. So we know where Europe is moving. And even there, we realize, okay, we need a start. It's not, 29 is soon, and there's a lot of technicians to be trained. Germany, another example, has a beautiful eco label. It's also described in the resource book, updated resource guideline book. Daniel will present, but I wanted to copy it in, and this is a good measure to promote green cooling equipment in the respective countries. So what we need is not just R290, we need training, we need qualification, we need certification, and we need registration. Only trained and certified technicians are allowed to work with flammable refrigerants. So we need to include the informal sector. We have developed a lot of training materials and even videos and so on, and online courses. And yeah, so we need to do that. We are doing it for over 30 years, or for 30 years now in our partner countries, and it takes time. Just these are the countries where we work in market introduction R290 and training on R290. I won't read all the names. Of course, we're working in more countries, but these are the major ones. We are currently still working on R290. AC. And globally, of course. And all GIZ offices are also have, the strategy is that they also are changing to R290 globally. One very short example, because the time is really running. We have a nice project commissioned by our Federal Ministry of Economic Affairs and Climate Action under the International Climate Initiative in Southern Africa, where we incentivizing 20,000 ACs, and we train as green split ACs, and where we are training technicians and also look at end of life. And I just wanted to show you the example. So this is how much rebate we are paying to promote the efficient and green ACs. Because they're more efficient, they're also a bit larger, and therefore they need more material, so they're more expensive. But looking at the overall life cycle cost, one AC in Namibia here can save up to 20,000 kilowatt, can save up to $1,200 US, and can save up to 19 tons, depending on the capacity. And that's up to 6 return travels from South Africa to Frankfurt, or approximately up to 60,000 kilometers. And I mean, I put some of the manufacturers here that already, I mean, a lot of production lines have been converted. GIZ converted the first production line in India and the first one in China. And a lot of it, a lot of the production lines have been converted already in China. And most manufacturers have already the equipment. Daikin just launched at the fair in Frankfurt, the R290 split AC. So things are moving. And looking at the green cooling network, that we promote cooling globally. So we have a green cooling network. Please join. Go on our webpage. You find a lot of information on green cooling technologies, also on split ACs. One more time, I mean, these are some of the publications. We updated the international safety standard just recently. Daniel will now present the R290 split air conditioner resource guide. There's other studies. You find more publications on our webpage. I think I'm done with my presentation. Thank you very much. I had to rush a little bit because Daniel also needs some time, and we want to keep some time for the question and answers. Thank you very much.
Thank you very much for your interesting presentation, Philip. If you have any question to Philip, please write it in the chat, and we will answer them after in our question and answer session. And now I would like to have the opportunity to present or to introduce Daniel Kolborn. Daniel specializes in environmental performance and safety aspects of alternative refrigerants and systems. He works closely with various organizations, many of them, including the GIZ ProClima, also manufacturers and end users. He is also an active member of several standardization committees, and particularly those that are focused on flammable refrigerants and air conditioners. Daniel, the floor is yours.
Hi, good day, everybody. Thank you, Paula, for the introduction. My presentation here is intended to cover the revised split air conditioner resource guide. This is just being published. As Philip mentioned, there are a number of barriers associated with the introduction of R290, or let's say hurdles, I prefer to call them. Of course, as most of you are familiar with, the most, or arguably the most significant one, are the safety concerns related to the flammability. Of course, there's also the lack of awareness of various stakeholders in across various countries. And again, similarly related to that, there is limited understanding or infrastructure for the correct handling treatment of the refrigerant throughout the lifetime. So that lifetime covers everything from the manufacturing, the installation, the in-use or normal operation, servicing, maintenance, and then at the end of the equipment life, decommissioning, dismantling, disposal of the equipment as well. So because of these hurdles, there is often some level of hesitance to adopt the technology. That is despite the quite considerable reduction in both greenhouse gas emissions that Philip mentioned in the previous slide, as well as potential reduction in energy costs and so forth. So the objective of this, the general objective of this resource guide is to try to help guide stakeholders through some of these issues. Ideally, it is intended to inform all of the stakeholders from whichever aspects they are involved from on these various factors which are deemed crucial for a successful transition to energy efficient R290 natural refrigerant split air conditioners. So in general, the guide should be addressing or providing information for those stakeholders who are making decision makers, handling topics of energy efficiency and refrigerant transition policy, provide a general understanding about the implication of using R290 as a refrigerant, and also providing some guidance to how to educate others that one may be speaking to. An important element of this is the issue related to standardization, and then also certification, training and so forth, which again was mentioned previously. And then of course there are a number of other knowledge gaps that are often in existence that hopefully this guide will try to address. A lot of the information, and much of the information presented in the resource guide, is largely reflects an accumulation within GIZ ProClima that has been gained from the various projects that have been carried out under the programme. So. This slide simply just provides a list of the contents of the resource guide. So first section deals with the technical design aspects, the refrigeration characteristics of the air conditioner. The second part addresses particularly the characteristics of R290 and how those impact on the design of the air conditioner. Third part addresses manufacturing, production lines and so forth. Excuse me. The fourth part is addressing the topic of safety standards, and in particular the revised safety standard for air conditioners. Next, is the important topic of energy efficiency and the related test methods, safety performance standards, and energy labelling. And related to that also is the eco-labelling that was recently mentioned. And lastly, obviously, we can't deal with this topic without mentioning the technician side, so refrigerant handling aspects, and the framework related to ensuring that that is carried out appropriately. So first of all, just providing an overview of the various alternatives for split air conditioners. I guess most of you are quite familiar with these. Starting from the left, you have R290, which is the historical refrigerant. Some people are still obviously using it. It's in the process of being phased out. Then let's say the first main refrigerant that was transitioned to R410A, R32, which is perhaps the most common fluid in new systems today. And then there are a variety of new blends comprising the HFCs and unsaturated or HFO refrigerants, which have got a marginally lower GWP but have other implications, and then the hydrocarbon, such as R290. There's a number of parameters that are mentioned and discussed in the guide in terms of the implications of these different alternatives. Importantly, from an environmental point of view, perhaps the most important aspect within the context of this discussion is really the global warming potential. And that of R290 is extremely low. It's effectively negligible, and substantially smaller than all of the other alternatives. But there are, of course, a number of other environmental implications. So, for instance, emissions of toxic substances during the production of these chemicals. One important point, perhaps, to mention is whilst R290 is historical or conventionally a fossil fuel, fossil gas, you can actually obtain, let's call it biopropane, or bio R290, which is produced from hydrolyzed vegetable oils. So it is actually possible to produce R290 without having to rely on fossil sources. There's a number of other implications. There's the cost of the refrigerants, the efficiency, which I'll mention in a moment. The constraints in terms of patents, but broadly R290 is not bound by patents in the same way as the fluorinated refrigerants. But of course, as the technology develops and people think of good ideas to adopt or to address the flammability, there are, of course, more constraints. We mentioned the training requirements. I won't touch on that now. And lastly, the most perhaps also a very pertinent aspect is the use restrictions. In many parts of the world, increasingly around the world, there are limitations being applied to the consumption of fluorinated gases. Europe is one mentioned earlier, and hydrocarbons or R290 are not generally subject to such restrictions. Now, next, focusing. Okay, focusing more on the performance. I won't spend too much time discussing this in detail, but what I want to show here are the selection of different thermophysical properties of the mentioned refrigerants. And when you consider these different thermophysical properties, you can get a good indication of what the so-called potential efficiency of the various refrigerants are. So, for instance, high critical temperature is exhibited with R290. That means much better potential performance at higher ambient temperatures. High latent heats means low mass flow rate. High specific heat thermal conductivities. Again, that contributes to good heat transfer or more effective heat exchangers. Low viscosity, this leads to better heat transfer and low pressure losses, so less energy losses. And this ratio of say the flat saturation temperature gradients of the refrigerant, the lower that is, that leads to a lower compression ratio and better compressor efficiency. So when you look at it from a excuse me, from a thermophysical property point of view, R290's definitely got is definitely substantially better than most other refrigerants. It doesn't necessarily mean that you're guaranteed to have good efficiency, but it means that with proper component design and selection, you can certainly achieve the most efficient systems. Okay. Related to performance, there was the subject of performance testing, so system performance testing, test standards, energy labeling, and eventually eco-labeling. So this is discussed in the resource guide. It's increasingly becoming quite a complicated topic. Historically, we just had single point performance parameters like COP, coefficient of performance, or EER, energy efficiency ratio. It's acknowledged that these don't necessarily reflect the lifetime performance. So there are a variety of different so-called seasonal efficiency measures that are listed here, and various national standards that are that adopt these different measures. So the guide hopefully tries to provide some guidance towards interpretation of these. Of course, when it comes to energy efficiency, the system, there are a vast number of different measures or features, technologies that can be implemented into the equipment design. Of course, none of these are magic secret techniques. All manufacturers are fully aware of them. I've mentioned them here. Well, perhaps one useful, important point to make is this. Of course, integrating a new or an additional technology into the air conditioner for the purpose of increasing the efficiency usually has some cost implication associated with it. So, for example, larger heat exchanger, use of an inverter drive, use of electronic expansion valve. There are, of course, cost implications associated with this. But I think what's useful to bear in mind is that the additional first cost of implementing these measures is usually just a fraction of the cost of energy saving over the equipment lifetime. So, for example, if you spend 10 euros on a slightly larger heat exchanger, you'll save 100 euros of energy consumption over the lifetime, approximately, for instance. So it's always a good investment to spend more in a more efficient design. Then on to the subject of safety, flammability safety in particular, which is generally the main hindrance. Within the guide, we address this in quite some detail. The flowchart on the right shows a general process to implement flammable refrigerants into the design. And this comprises mainly of reducing the likelihood of leakage, avoiding potential ignition sources, and applying other measures, and then going through this iterative cycle, trying to minimize the flammability risk over the equipment lifetime. There's a number of measures here. So this first slide mentions leak reduction, which is important regardless of the refrigerant using, flammability or otherwise. But there's a few options mentioned here and more detail provided. Then avoidance of potential sources of ignition on the equipment itself. So using so-called EX type components, slight redesign of fans, contactors or relays that are enclosed or solid state, or applying so-called leak simulation tests. Also implementation of measures to help disperse leak if it does happen, so achieving minimum airflow or redesigning the indoor unit enclosure to help encourage dispersion of that leaked refrigerant. There's further measures that can be implemented. So, for example, use of gas detect or leak detection. So you can implement leak detection and then take response actions to try to address that leak. Leak detection doesn't only comprise gas detection. It can also use ultrasonic sound from the noise of the leak itself, or monitor system parameters such as pressures, temperatures, and so forth to indicate a leak. The protective, excuse me, the protective measures that can be implemented may be to switch off the compressor, switch on unit fans to disperse the gas, closing solenoid valves to prevent further release of the gas. Another important aspect that a lot of people are investigating at the moment and have been for a while is reduction or minimization of refrigerant charge. So using smaller heat exchangers, smaller tubes, redesigning compressors and so forth. All these aspects contribute positively. And then perhaps the last main element is ensuring proper signage and information to the user, but mainly the installer and service personnel. But it mentions the revised safety standards. This international IEC 60335-2-40, which is specifically safety requirements for heat pumps, air conditioners, and dehumidifiers. This was revised about and approved about 2 years ago, just longer than that. In fact, there's the next edition that's being sent out for vote at the moment, which is similar to the current one, but just with a few refinements in it. The previous editions of this standard were extremely restrictive in terms of A3 or hydrocarbon refrigerants, but fortunately this new edition is a lot more beneficial. The graph here on the left shows the allowable refrigerant charge in relation to the room size, the room floor area. These three lines on in blue that you can hopefully see reflects the charge limits from the previous or the historical standard. And it is these limits, not the upper charge limit of 1 kilogram, but these limits per square or per unit of room floor area. These were very restrictive. The revised standard provides all these new options for allowing a lot more refrigerant per square meter, whilst maintaining a high level of safety and avoiding the possibility of potentially flammable mixtures occurring in the event of a leak. standard covers all these topics that I've listed on the right, and this is detailed in the resource guide. Crucially, following on from what I mentioned before, this graph on the left shows the quantity of refrigerant contained within different air conditioners. The green crosses are air conditioners, or R290 air conditioners. The other data points are R32 or R410A units where I've adjusted the charge according to that if R290 was used. The point that is being shown here is that with the previous version of the safety standard, almost none of these products would be permitted by the standard. So, for instance, this red line here, that's the charge limit for wall units, and as you can see, it would only capture a few models. Now, with the revised standards, these the blue, turquoise, and purple lines, depending on which safety measures are implemented, you can see that virtually all products can be handled or implemented by the revised safety standard. There's a few systems up here which exceed the upper charge limit, but for the same cooling capacity, that a smaller charge can also be achieved. And then lastly, as we mentioned before, there's the importance of the infrastructure for refrigerant handling. So refrigerant handling, for instance, during installation, maintenance, service, repair, decommissioning, disposal of the equipment, and the requirements for technicians, and again the qualification, certification, registration, and provision of the correct tools and equipment was mentioned earlier on. The resource guide also includes a variety of sort of little case studies here, covering various stages that should also be of interest to stakeholders. So, quick run through it, but just a couple of final remarks. The resource guide, it sort of just touches on a variety of subjects, but should hopefully provide a useful overview. And obviously, you know where to come if there's further questions or inquiries to be answered. One last point that reflects the historical experience with these types of equipment. There's a lot of gossip and whinging and complaints and concerns about the flammability risk. And I'd say 99.999% of this is unjustified. It's done for commercial reasons or whatever. What we do is carry out systematic, rational, quantitative risk assessments on the design of air conditioners and other equipment. And from this type of exercise, what we find is that the flammability risk is extremely small. So, you know, in the order of, you know, 1 in 100 million per year or 1,000 million per year, infinitesimally small. Compare that with the, let's say, the background risk of air conditioners and refrigeration equipment, which is 1 or 2 in 100,000 per year, fire risk, which is due to, for example, electrical faults and so forth. The flammability risk associated with these split air conditioners using R290 is extremely small. And so when you consider this within the context of discussions about flammability, It's not to say that it should be ignored, but it should not be used as a basis for arguing against the technology. So with that, thank you very much for your attention, and back to Paula. Thank you.
Thank you very much for your presentation. It was very interesting, Daniel. So I have seen that we have some comments in the chat, but I'm afraid that we are not going to be able to answer all of your questions since we are running out of time. But I have picked some of them that I would like to put at the moment. One comment was related to from Gabriel Rena. Do you work on other green cooling technologies which are not ACs? For example, on cooling vests or cooling apparel to cool only the people, but not the whole rooms, which needs much more energy. We received the German Sustainability Awards for such solutions. Is that interesting for green cooling of GIZ to have more options? Perhaps you can answer, Philip.
Yes, thank you for the question. Of course, we promote green cooling in all subsectors, meaning doesn't matter if it's commercial or domestic refrigeration, if it's industrial, if it's, I mean, we also work in the foam sector on blowing agents. So yes, I mean, send us the information about what you're doing, and we see if we can cooperate or work together on it, promote it, become a green cooling member. There you already have a chance to get visible on our webpage, but let's work together. Yes.
Thank you very much. And also I have seen some comment from Chantel Wellington. What are the requirements for other countries in the Caribbean to be able to partner with GIZ projects focused on R290 AC splits?
Yeah, thanks, Chantel. Yes, I mean, we've talked in the past, and we, of course, our funds are also limited, and we can't work with all the countries. We work currently with 40 countries. We would love to work with more countries, also in the Caribbean. So luckily, we always have some projects where we can work, and in the Caribbean also, like with Grenada, but also with Trinidad, we had some activities. And yes, I've been to China like 2 weeks ago, and I've talked to some manufacturers this week again. I really try to help to set up a supply chain of R290 air conditioners for the Caribbean, so that you all are getting access to the technology, because we have the chicken egg problem, and also if there's not enough demand, many manufacturers don't want to export just a few units. But if we bundle it in the Caribbean, yes, we can definitely, I mean, you will have some market size, and I already got the contact now of one salesperson for the Caribbean of a major manufacturer that they can also share with you, that is responsible for the Caribbean market. But we can also think about organizing something for the Caribbean, some trainings or whatever, as part of our new project, the Green Room Air Conditioner project.
Thank you very much, Philip. Since we are running out of time, I'm afraid that we are going to be able to answer your questions by mail. And also, before we are closing the session for today, I just wanted to invite everyone who is not part of the Green Cooling Network and the Climate and Ozone Protection Alliance to become a member. We are happy to hear from you, and if you are interested to join, you can also find the information in the chat as well. And also, I would like just to make a short reminder for the tools from the cooling sector, also in order to introduce the RAC sector in the NDC. We invite you to visit our NDC help desk. It's your resource for experts' guidance in the field of green cooling. Our mission is to assist policymakers in designing and implementing ambitious NDCs in the cooling sector. Also, our help desk includes a contact form, but also the most frequently asked questions regarding NDCs in the RAC sector, and a and many publications as well. So you can find the link in the chat, and we will be very happy to receive your questions as well. And finally, in name from the GIZ ProClima and also the speakers that were today with us, I would like to thank you, all of you, for your participation, and also we hope to keep you in touch with you and also to see you in our next webinar that is going to be next week on the 10th of April, and we will share the information with you soon. Thanks again for joining us today, and take care. Goodbye, and I will really appreciate to see you again. Thank you very much.